Alright, welcome back to part 2 of our lecture. Now we're going to kind of break down further this whole story about cloud classification into the individual cloud species. Now, again, I told you a little bit about Luke Howard. I actually find the whole story of Luke Howard, the man who named the clouds, fascinating. And he was trying to put together a system to name the clouds. And I'll be honest, it isn't entirely consistent as to how it all works and so on. But he was trying to figure out a way to use these words like cumulo, or cumulus, or cumuliform, or alternatively the words strato, or stratus, or stratiform, and hook those together with words that describe the height of the clouds to be able to talk about a way to label the different types of clouds. And so we're going to, in general, put a prefix onto words like cumulus and stratus that describes the height of the cloud. There's going to be CIRROCUMULUS or CIRROSTRATUS, which will be the high clouds. Now, by high, we mean like in the upper troposphere. Or there'll be alto. Alto meaning like mid-level, like alto saxophone or something like that. That means like middle troposphere, like ALTOCUMULUS or ALTOSTRATUS. We'll see those examples in a little bit. Or if you don't put any prefix in front of it, it'll be low, meaning like in the lower troposphere. Now that's all well and good, but I actually don't entirely know how that worked, because as much as we always teach the class about like how Luke Howard did this, the truth of the matter is the tropopause hadn't been discovered yet, so I'm not entirely sure how he knew about the different heights of the troposphere, but he certainly understood that some of the clouds were lower, some of them were in the middle, and some of them were higher. And I don't know if I got this picture from your textbook, but your textbook will certainly have a figure very similar to this, where it kind of tries to sort out and show you how we're going to be labeling the clouds. For example, we're going to use this word cirro to talk about our high clouds. Your book says maybe higher than 6,000 meters, that's 6 kilometers up, or about, what, I don't know, 4 miles or more. Basically, remember the troposphere is the lowest 11 kilometers or so. So at least, you know, the top half of the troposphere or whatever. And you can see that that's going to be like our CIRROCUMULUS clouds and our CIRROSTRATUS clouds. We'll also have something that doesn't fit either of those categories very well, just cirrus clouds. Or we'll have mid-level clouds, which are going to be the ones with alto in their name. They're going to be more around 4 kilometers, that's like 2 miles up or something like that. That's going to be where we're going to have species of clouds with names like ALTOCUMULUS and ALTOSTRATUS. Or we can have no prefix on the beginning, and this is going to be where our low clouds are, where we're going to have near the surface clouds like cumulus and stratus. They'll also be these sort of ones that don't fit the system very well, like STRATOCUMULUS and NIMBOSTRATUS, but we'll get there as to what all that means. And finally, there's one that doesn't fit the system at all, and that is Cumulonimbus. Cumulonimbus clouds are thunderstorms. We have a whole module coming about thunderstorms, but we'll talk about them just a little bit right now. Well, in this part of the lecture anyway. So let's start taking this apart. Let's start with one that doesn't fit the system so great, and that's CIRRUS. CIRRUS. No cirro, anything attached to it, just CIRRUS. Cirrus clouds are very high, very cold, they're made completely of ice, and they are those thin, wispy ones that look a little bit like feathers. They can be remarkably thin, and they have a lot of impact on like the radiation budget, because they're very good at reflecting shortwave radiation back up into space, and they're also fairly good at absorbing longwave radiation and re-emitting it back down towards the surface. They're important. They never produce precipitation. Cirrus clouds are unrelated to precipitation. Partly that's because there is no Bergeron process going on inside of a cirrus cloud. A cirrus cloud with only ice in it has no supercooled water. Remember, the Bergeron process, your cloud needs to be made up of mostly supercooled water with some ice. Now it's all ice. Don't worry about the Bergeron process. Plus, they're just so damn high that even if some kind of like ice crystal or, you know, whatever formed that was big enough to fall out of a cirrus cloud, it's 6, 7, 8 kilometers up. It would certainly evaporate in this subcloud layer of a cirrus cloud. So there isn't going to be any precipitation out of any of these cirrus clouds. Your textbook, your lab manual, places like that, will often refer to these kind of clouds as mare's tails. Mare as in like a horse. And the idea is, you know, that fibrous appearance of the cirrus clouds it kind of looks a little bit like the flowing mane of a horse or a horse's tail or something like that. I always wonder why they dwell on things like that. I mean, it isn't the 18th century. Not that many people are, oh, it looks like an old mare's tail out there. What are we, 17th century whalers? I don't understand why they tell us things like that. Now, while we're up there at those high clouds, though, there are other species up there than just cirrus clouds. There are cirrocumulus clouds, for example. Cirrus clouds are a cumuliform cloud occurring in the upper troposphere, and here's a picture of them. Let me give you an important point about cirrocumulus clouds. Cirrocumulus clouds do not occur individually. They always occur as a group or a field. We actually have a cool word to describe that in meteorology. Types of clouds that don't occur singly, they always occur in groups. We describe them as being gregarious. We use that word gregarious a little bit loosely in English. We tend to use the word gregarious thinking it means like friendly. But gregarious means only seen in groups. Sheep are gregarious. Okay, they're a flocking animal. They occur in groups. There are other ways in which we could use the word gregarious, but gregarious means occurring in groups, and cirrocumulus clouds are gregarious clouds. Now, in this picture, there are several hundred of these cirrocumulus clouds. Each represents an air parcel that rose to its lifted condensation level and then rose a little bit farther. Now, you might be thinking, Dr. Shragi, why didn't you find a picture of them where they were bigger? But this is actually helpful to you because I want you to have an important idea about the cumuliform clouds like cirrocumulus. Not perfectly, but to a pretty good approximation, all the cumulus clouds are about the same size. So if they look small, they're farther away. This field here of these gregarious cirrocumulus clouds, each cloud looks small, but that's just because they're way up there. They're maybe 7, 8, 9 kilometers up. So they look much bigger than like a low-level cumulus cloud, which, might look pretty big, because it's just closer to your eye, okay? So here's some nice cirrocumulus clouds. Again, it's a classic thing for meteorology textbooks to refer to these as mackerel sky. Again, what do they think we are? We live in a lighthouse in the 17th century? I mean, I get it. The sky kind of looks like fish scales or something like that, where there are zillions of individual cirrocumulus clouds. Notice they also tend to occur in like billows, those lines of clouds. Yeah, I mean, that's where the word mackerel sky comes from or whatever, if you've ever heard that expression before. We talked about, among our high clouds, we talked about cirrus and cirrocumulus, but there's also cirrostratus. Cirrostratus would be a stratiform cloud in the upper troposphere, in the high levels. And so here's a cirrostratus cloud. Now I want to draw your attention to what is the cirrostratus cloud here. See how there's kind of like a little puff of cloud, kind of almost right in the middle of the picture right here? Like at about 11 o'clock or something, if this thing looked like a clock? That's not it. That's just something else in the field of view here. The whole sky is covered with cirrostratus here. Cirrostratus clouds are very thin. There is not much ice between your eye and the sun when there's a cirrostratus cloud between your eye and the sun. Okay? They are not very opaque. They let almost all the sunlight through. So they're hard to see. In fact, typically the best way to see it is to look in the direction of the sun or the moon and see a halo. Okay, especially at night, a halo around the moon is a very good sign that there are cirrostratus clouds. They are often subvisible, as in it's difficult to see them with your eye. They're barely visible to the naked eye, but they can in fact still be very important and represent a complicated challenge in meteorology because they do play a role in our radiation balance. Even if they are hard to see with your eye, they might be reflecting a fair amount of shortwave radiation, keeping the surface cooler, or they might be absorbing a fair amount of long-wave radiation that the surface of the Earth is emitting, and then re-emitting that radiation back to the surface. They could be part of the greenhouse effect. Either way, eek, that's complicated stuff for those relatively innocent-looking cirrostratus clouds. Let's move down now. We've talked about the high clouds, the ones with cirro in their name. Let's go to the mid-level clouds, the ones with alto in their names. The ones that are in those levels are going to be, maybe 4 or 5 kilometers above the surface of the Earth. They're cold, they're below freezing, they're below 0 degrees Celsius, but not like spectacularly cold. At those temperatures, clouds tend to be a mixed cloud, a mixture of water vapor and liquid water and ice. Of course, if there's liquid water and ice in the same cloud, clearly that ice clearly that liquid water is in the form of supercooled water. So like if we took a really close look inside of a cloud here, like is in this picture right here, we have supercooled water droplets, that's the circles. We've got lots of water vapor, that's those little red water molecules in there. And we have some ice crystals, which they drew in here as a snowflake. So they're mixed clouds. The Bergeron process is going on in them and so on. But they are different. Their composition is different than the cirriform clouds. Alright. Let's talk about some of them. ALTOCUMULUS. ALTOCUMULUS clouds are cumulus clouds. They're formed by air parcels that are rising through air that around it that isn't rising. And they are formed in the middle of the troposphere. So they're usually a mixture of ice and supercooled water. ALTOCUMULUS is a lot like CIRROCUMULUS in that it is a gregarious form of clouds. It is a gregarious species. That means it always occurs in groups. And if you look at this picture, they look bigger than the pictures that we saw of the CIRROCUMULUS clouds. And that's a good reason for that. They're just closer. Whereas CIRROCUMULUS clouds might be 7, 8 kilometers up, these guys might be more like 4 kilometers up. They look bigger. I'm sure that that some meteorologists would object to that generalization, but broadly speaking, if a cumulus cloud looks bigger, it's just closer to your eye. So these are ALTOCUMULUS clouds. Again, ALTOCUMULUS clouds tend to occur in waves or billows. Billows is a more technical term. Like, you know, each of these lines that you see here on this picture here is a set of ALTOCUMULUS clouds occurring side by side. Okay, it's not important at this exact stage to know why they occur that way, but they tend to occur in these waves or billows. Again, they're gregarious. You never see one ALTOCUMULUS cloud. You see hundreds of them at one time. And they're easy to tell from their stratiform alternative, the ALTOSTRATUS clouds. ALTOSTRATUS clouds would be a stratiform cloud occurring at mid-levels of the atmosphere. Here is an incredibly bland-looking picture of ALTOSTRATUS clouds. I mean, I guess I see gray sky. I guess I kind of see something fuzzy over here. What's going on? Well, that's actually right. ALTOSTRATUS clouds are really very featureless. Pretty much the sky just looks white or gray. And they're not particularly thick. The sun can shine through them. So, like, you'll typically see the sun in the form of a disk or a bright patch in one area, like you see kind of here over by the Eiffel Tower. And this is an ALTOSTRATUS cloud then. You can identify it during the day anyway because it's thin enough that that you can see the sun through it. I mean, you can't really see much of anything else about the cloud. It isn't like somehow there's some features you could look at with your eye. It's just gray or white. But you can tell by how the sun is shining through it that it must be an ALTOSTRATUS cloud. Again, here's some more pictures of ALTOSTRATUS clouds. Basically, it's more or less featureless, covers the sky. The sun can kind of make a bright patch or a disk as it shines through it because the distance between the bottom and the top of the cloud is not very high, and as a consequence, you can get some sunlight through them like that. After talking about the cirrus clouds and about the alto clouds, the high clouds and the mid clouds, let's talk about the ones that are closer to the surface of the Earth. And those we generally don't attach a prefix to, like cumulus clouds. So here's some happy cumulus clouds. This happens to be a famous picture taken by a famous meteorologist, well, actually it's Tor Bergeron, as in the Bergeron process. And it was the cover of a textbook that he wrote and so on when he was at the Grand Canyon. And you can see how we have some cumulus clouds. They are clearly cumuliform clouds. Air parcels are rising, reaching their lifted condensation level. That's how you see their flat bottom. And then the air parcel continues to rise to make the puffy part of the cloud. Okay. They look pretty big compared to the other pictures of cumulus clouds that we saw, but of course it's just because they're closer. I mean, that cloud's only, excuse me, maybe a couple hundred feet away. It might be a little bit farther away than that, but not terribly far. As we've said before, cumulus clouds are generally going to be flat on the bottom and puffy on the top. It's going to be their lifted condensation level is going to define their bottom, and then the air parcel will continue to rise as far as its momentum takes it, and you'll be able to make them kind of puffy on the top like that. And so you kind of get some pictures of what we mean by a cumulus cloud. Cumulus clouds do not necessarily occur in groups. They are not necessarily a gregarious type of cloud. And you can, on a day, look outside and say, oh, it's really beautiful, it's very clear, and oh, look, there's one cloud over there, one lonely little cloud. Yep, That can happen. Cumulus clouds there can just be one of. Again, it's a little beyond the scope of the class as to why that happens and so on. But cumulus clouds are very different than the low-level clouds that are the stratiform clouds, or stratus. Stratus is a stratiform cloud that occurs near the surface of the Earth. And it's not very high. I mean, it's often the case that on a day when there are low-level stratus clouds, tall buildings reach up and, you drive into downtown Omaha and the First National Bank building or the Woodman building will have its top in the clouds. Or some tall towers, like radio towers or whatever, are up into the clouds. And they can be awfully close to the ground. I mean, maybe 200-300 feet up. And they're close enough that you can usually actually see some structure, like some places where the base of the cloud is a little closer to the ground, or maybe a little farther from the ground, or maybe you can see some movement around the bottom of the cloud as some winds are moving some cloud material around. You can actually see some structure just because they're not that far away. So, like, here's a lovely picture of some stratus clouds, and I can tell a little bit by looking, there's some places where it's a little thicker, places a little thinner. I can see it's places where it's a little bit lower, places where it's a little higher. It's so close we actually don't have trouble seeing little features of these otherwise rather bland layers of clouds. The trick with stratus is to tell it apart from stratocumulus. Stratocumulus, that name doesn't really fit the pattern very well. Yeah, stratocumulus, which kind of just sort of, like a portmanteau or whatever, we've run two words together. Stratocumulus clouds are when there's a whole layer of cumulus clouds occurring side by side. And that can be hard to tell from a stratus cloud. But you should be able to see like little patches where you're either seeing the sides, these cumulus clouds are not quite touching each other, so you might see some blue sky between them, or you might see the side of one cloud in the gap between two clouds. Some of these other pictures might make it a little bit more clearer. Where this is not a whole layer being gently lifted, it's a whole bunch of cumulus clouds occurring side by side. The right word for that is stratocumulus clouds. Another word that wasn't very well anticipated by Luke Howard's original system was nimbostratus clouds. Nimbostratus. Nimbo, we use the word to mean something like raining. Okay, that's not exactly right from like Latin or something like that, but it works. We're going to say that a nimbostratus is a stratiform cloud that's low and producing precipitation. So typically nimbostratus clouds are producing like gentle rain, drizzle or something like that. They're just sort of long, protracted, light rain. From just falling from a fairly low, featureless cloud. Picture that like drizzle or something like that. The main reason we talk about the main reason we talk about the nimbostratus is because the alternative, cumulonimbus, is quite the beast. Cumulonimbus clouds are thunderstorms. Now again, we have a whole module about thunderstorms, I think it's module 6, but we can talk about them in the context of what their clouds are in just a little bit. I mean, right now, rather. Cumulonimbus, a cumulus cloud nimbus that's raining. It's a thunderstorm, and it has a lot of vertical development. The base of a thunderstorm will be quite close to the surface of the Earth, maybe a few hundred feet up, and the top of the thunderstorm, the cumulonimbus cloud, will be up near the tropopause, maybe 11 kilometers up. This is a big, tall cloud. It is a cumuliform type of cloud, which means that it is formed by an air parcel that is rising to its elliptic condensation level and continuing to rise upward at the moist adiabatic lapse rate. It is a cumuliform type of cloud, and really when you start looking at some of them, it starts becoming clear that we're talking about a very large cloud. Much, much larger than any of the other clouds we've seen before. Here's this picture of a cumulonimbus, a thunderstorm cloud. If we were talking about a single cumulus cloud in the same neighborhood, it would just be a little bloop, the size of a couple pixels on the screen right here or something like that. This cloud is vastly larger than a cumulus cloud. Its rising motions are also very strong. The rising motion in a cumulonimbus cloud might be 50 to 100 miles per hour. Okay. The rising motion in a cumulus cloud might be a few miles per hour. Rising motion in a stratus cloud might be a few centimeters per second. I mean, virtually nothing. One feature that is often the case of cumulonimbus clouds is that they will have an anvil. This is where the rising motion of the thunderstorm or the cumulonimbus cloud hit the tropopause and started spreading out. think of it like a plume of smoke rising, hitting the ceiling, and spreading out. We're not yet ready to explain why the tropopause, the top of the troposphere, is something like a ceiling, but it is, okay? I think it's in the 6th module we will explain why rising plumes of air from the troposphere can't get through the tropopause. We're not there yet. But as it spreads out, it makes that shape that is called an anvil. The anvil is like way up near the tropopause, and it's spreading out above a cumulonimbus cloud. Anvil, as in like what a blacksmith beats metal on, you know, like a to make a horseshoe or something like that. It's the shape of it. We call it an anvil. Gosh, we just had a whole lot of information. How's the test going to work about stuff like that? Well, first off, we just have some word questions. I mean, on their blue line test, there'll be questions about things like, put these clouds in order from lowest to highest, or which one of these clouds is made completely of ice, or which one of these is formed by rising motions in the atmosphere. Hint, all of them are. That would be one way in which we could do the test questions, but there will also be pictures of clouds on blue line. And sometimes I'll have like 4 pictures of clouds, and I'll say which one of those is the cirrostratus cloud, or maybe there'll be a picture of a single type of cloud, and it'll say which of the 4 types of which type of the following 4 types of clouds is that. I want to emphasize something. They are not designed to be tricky questions. We're going to do some examples of these questions at the end of this part of the lecture, just so you get a sense. The choices that you'll get are very different. Okay? I'm not going to show you a picture of clouds and give you the choices of CIRROCUMULUS or ALTOCUMULUS, for example. Well, actually, it would be hard even for like an atmospheric science major to tell the difference between that without more information. Your 4 choices will be 4 types of clouds that look very different. Maybe Cumulonimbus and CIRROSTRATUS and ALTOCUMULUS. Okay, they are types of clouds that look very different. Clearly one of these is the right answer. Now, students often want to know, how am I going to get more information about this? Well, first off, obviously your textbook. The textbook reading about the different types of clouds is excellent. I also got most of these images from Google Images. I bet you're not surprised by that. That's another great place to get some example. Google CIRROSTRATUS, and you'll see lovely examples of CIRROSTRATUS. Google STRATOCUMULUS, you'll see lovely examples of STRATOCUMULUS. Wikipedia also is an excellent reference with lots of examples. But you know what? Honestly, my favorite place to look for pictures of clouds is the website of the Cloud Appreciation Society. And yes, there is such a thing as the Cloud Appreciation Society. And they archive pictures of clouds for use in teaching and the betterment of mankind or whatever. They have a great archive, by the way, of clouds that look like stuff. You know, here's a cloud that looks like a Dorito. Here's a cloud that looks like a dog. And it's a hoot. Anyway, I love the Cloud Appreciation Society. And they have a big archive. If you want to see lots of examples of CIRROSTRATUS or something, browse there. It'll be great. Alright, as we wrap up this lecture, let's answer 3 quick questions. Question 3. Here's a picture of some clouds. What kind of clouds are that? Boy, there's definitely questions like this on the quiz in the pool. Is that a cumulonimbus cloud? Is that stratus? Is that altocumulus? Or is that cirrus? This is a good example where the types of clouds listed there are all very different. Which one is that? Make a choice from the 3, 4 options below and get some feedback before you move on to question 4.